Okay, well, almost to the end of distribution of description of the distributions of the samples. We've done shape, and we've done centers and shift. I now have a video with a full practice template of what you should have written for practice 1. I haven't done anything with practice 2 yet, but I will get to that. And then today we're going to go through excuse me, overlap and spread. Now I'm going to spend some time on overlap because overlap is quite important for making some decisions about what's going on in the sample. Again, if you've had inference in level 2, will be a review. If you've not had any inference before, this will be a little bit onerous, and it will have to be sort of looked at probably a couple of times. So, excuse me, overlap is about the boxes, the middle 50% of the box plots, and it's about whether they overlap or not and how much overlap they have. So it's important because the more that the groups overlap, the more similar the groups are statistically. So I've got this little graphic here, and the fact of the matter is you can see that for group A and group B, there's a big old distance between them. They don't overlap at all. And so when you have a situation where box plots don't overlap at all, then you can it's pretty safe to say that there's a fairly substantial difference between the samples, and that B is bigger than A in this case, or taller, or whatever. And that because there's so much difference between these samples, it's probably also a fairly safe bet to say that back in the population there's a difference between the two groups. So that's a fairly straightforward situation, but as we go down here, we can see that the box plots get closer and closer, and until we get sort of at the bottom where we kind of have that situation like we did with the shoulder widths, where one box is completely overlapping the other. So in this situation, this extreme situation here, you would say that in the sample there's no difference between the group A and B. They're very, very similar, in fact almost exactly the same. And so in that case, you would say that there's no difference between the two samples, and you would probably say that back in the population, we could say that there's safely no difference between the two groups, A and B. But there's sort of this gray area between the extreme, lots of difference between them, and no difference between them, that we have to kind of decide what we have. So we use something called a 3/4 half rule in year 11 and 12. We refined it a little bit, but we can sort of still use the 3/4 half rule to help us out a little bit with making decisions about what's going on in the sample, and then what we might want to say about what's going on in the population. So with no overlap suggests they're quite different from each other, the two groups in the sample, and gives us a solid indication that back in the population there is likely to be a difference between the two groups. If there is an overlap, then it's more uncertain if there is a difference between the two groups back in the population. Now, some of you would have used the 75%, 50% thing, and so what happens is when you look at, there's no overlap here between the boxes, and the other thing that you can notice is that the medians, both medians in this case, are outside the box of the other. So B's median is outside the box of A, and A's median is outside the box of B. So that's a pretty good indication that there is a distinctive difference between these two groups. Now we start to get where we have some overlap. So it becomes less clear, and you should be able to identify how much overlap there is between these groups when you talk about them. But if boxes overlap, but not so much that the median, at least one of the medians is outside the box of the other. So if you take a look here, we can see that B's median is outside the box of A, and in fact A's median is outside the box of B. But they don't have to both be outside the box, just have to have one of them outside the box, because what that does is that basically gives us this whole 3/4 or 75% situation where we can say that 75% of all B's data is bigger than 50% of all A's data. So that's where that 3/4 half rule comes in, 75%. bigger than 50% of A, so 75% of B is bigger than 50% of A. When you have that kind of situation, generally, we say that we've got this 3/4 half rule, and so that we can say, although there's some overlap, we can still sort of say in our sample and maybe back in the population that there's a difference between B and A, and that B is bigger than A. And conversely, if you have it sort of in the opposite direction, where so this is sort of the situation where you've got, again, 75% of B being bigger than 50% of A. So you've got that 3/4 half rule there. And then if there's so much overlap that you cannot basically say that one meeting is outside the box of the other, that basically this is the median of B and it's inside the box of A, and this is the median of A and it's inside the box of B. So there's so much overlap that we can't say that there's a difference between A and B, that A and B are too much overlap, and so there's too much similarity between them to say that back in the population there's difference between A and B. And remember, we're trying to decide based on our sample what we can infer back to the population always. But we have to be very tentative about doing it with the sample and our point estimates, because using the point estimates, which is the medians, we know that we have sample variability that comes into play here. And sample variability means that we take a sample and we may get this story, but if we take another sample, maybe we get this story. And so because of sample variability, this is not the best way to determine what's going on back in the population. That's why we move to the next phase of things, which is what we call the confidence interval, where we get to be a little bit more sophisticated about how we make the call. But we can basically sort of talk about the sample and what it might mean back to the population. So the more overlap, the similar the samples, the more similar the samples, the similar the samples, the less likely there is going to be a difference between the groups back in the population. So this 3/4 half rule can sort of guide you along. And so we take a look at this example here, and we see that there's some overlap between the boxes, and you should define that overlap in your description. In this case, it seems to be that most of the overlap is between the lower quartile and the median of the males, and that's 25% right there. That's 25%. So you say the obvious thing. The obvious thing is that there is, in fact, an overlap between the middle 50% of the female and male distributions. So you say the obvious. And then you have to talk about the evidence. Well, why are you saying that? Well, if my eyes were closed and I couldn't see the box plots, then I have to describe exactly what I'm seeing. About 25% of the data between the two groups overlaps, right? So that's this area in here. That's about a 25% overlap. And then you can talk about, well, that's between the females median is 41.5, right, which is here, and the upper quartile at 44. So that's where the overlap happens, between 41.5 and 44. And then we can go a little bit further, because then we can talk about, well, about 50%. So about 50% of the male shoulder, which is right here. This is 50%, right? In here. Because that's 25% and 25%. So that's about 50%. And about 50% of the male shoulder widths are greater than 75%, which is that much, of the female's shoulder width. Right? So we've got that, we've got our 3/4 half rule happen, right? 3/4 half, because that's the 75% and the 50%. The other thing is that, excuse me, if we look at the medians, see the median of the females, which is 41.5 here, that is just barely inside the median or the lower quartile of the males, but oh, so close, right? Looks pretty much right on top of it. And the median of the males, 44, is exactly on the upper quartile of the females. So there's no median that clearly seems to be outside the box of the other. So that's sort of something else that we can talk about, and at least we can mention it here. And then when we go down to sort of make a decision about what's going on in the sample, we'll use this information to sort of help us out. So that's all about overlap. Lots and lots of things to know about the overlap. Spread's way easier. Spread can be the standard deviation, which we weren't going to talk about today, but interquartile range, which is just the box. How wide is the box? And it appears as though the male box is wider than the female box. That's called the interquartile range. The male's middle 50% is more spread than the female's middle 50%. What's the evidence? Well, this is where you actually do a calculation. You simply subtract the upper quartile from the lower quartile. And in this case, the male's interquartile range is 6.25 and the female's is 5. So the male's interquartile range is a little bit bigger, a little bit more. So that suggests that the interquartile range shows that the middle 50% is more spread out, with an interquartile range of 6.25 versus the females at 5, meaning that they have more variation in their shoulder width. So that's what spread tells us. Spread's pretty straightforward. And it tells us about variation, right? So what does this mean to the sample, and what might it mean to the population? Remembering that sample variability may mean that if we took another sample, you could get a very different picture. With a bigger interquartile range, it tells us that in our sample, the middle 50% of the male's shoulder width is more variable than the female's shoulder, and the sample meets the 3/4 half rule, but only barely. So I am not certain we can say there is a difference, right? We've got it there, but it's a bit dodgy. And then what does this mean to the population? And then if you were doing excellence and so on, you would link this to research, or what you would link it to your hypothesis. Because no meaning is clearly outside the box of the other group, this may suggest that there is no difference between two groups back in the population, but it does meet the 3/4 half rule, and one group is shifted a little bit further to the right. There is actually a shift to the right of males. They have a bigger median. But maybe there's just too much overlap to really say. And so we're left in this kind of limbo about, should we say there's a difference? Shouldn't we say there's a difference? We can sort of indicate from our sample what we're seeing, but can that sort of give us a clear indication about what's happening in the population? And that's where we go to the whole other half of this internal. But for now, we're just going to stay here, okay? So that's spread and overlap.